However, this is Bradley. People asked me about this animation earlier, so I'm making a tutorial for this. One thing I really need to remind you is that this tutorial requires a prerequisite that you need to watch the shader motion graphics tutorial example 2 first. You can use the link in the card or go to the description where the link is provided. Only after you know such a concept, then I recommend you to watch this tutorial. The second thing is that I hope you have your animation node up to date, because I may use a feature which may not be available several versions ago. So let's start. So here's a low poly tree I imported from the project file. I'm not good at modeling, so I don't want to really tell you about how I model this. Actually, I will, because it's actually important. But I'm not gonna. I only talk about several important principles. So within a cube, you basically need two shape keys. And let's take a loop cuts for a even number, and then you loop cuts again, and then you try to basically remember to Alt Z so that you select all the points. It might be better if you go to also graphic views, and you can just try to enlarge that, and then select every second edges. Actually, every second, yes, with an additional one at the bottom. And then I will take a vertex group and assign that just for safety. And then I'm going to enlarge that GZ, something like that, and shrink that. Basically, this is actually all about it. And I can do some more stuff, and you can select every other ones, like to increase its size, something like that. You can definitely make it better, but this is kind of idea. To add the randomness, you can potentially, so let's select, so let's not deselect everything and select our attached group. And I'm going to hit Control I to select the rest of vertices and hit H to hide all of them. And then I'm going to use the proportional editing, the random, and just move any points and increase the size of the proportional editing. And then I'm going to Alt H dehide. Then you can see only some points being affected while the others not affected. So this is kind of idea. Just next time, remember to take the top one as well, probably. But this is kind of ways to model a low poly tree, and I suppose you can definitely do better. But the important point is because you have the shape keys, so this is the way you can edit that. The next thing that you need to do is that I'm going to generate two materials, one material and the other material. So let's name as a trunk, and the other as leaves. Let's go to the basis. Yes. So now I see everything clearly. I think I'm going to select the faces, basically all the top faces, and assign them to leaves. And by default, the rest shader should be cubes. So let's take a look with the colors. Turn that to brown and leaves to green. And it works perfectly fine. Okay, so this is the basic setup for our unit. And finally, if you do everything is well enough, you will get a very nice low poly tree. There's an additional way that you can generate randomness of the low poly tree, but I don't think I'm going to cover that in this tutorial. The next thing, we are going to use animation node to do all the transitions. Because the old tree looks nicer, so I think I'm going to use the old trees. And let's switch the old tree materials into the new trees. So now I have a trunk and the leaves, which is nice. And let's go to shader. I'm going to switch to the objects. and I'm going to set that to trunk. So now you see I cannot get two windows at the same time, but if you paint that, then you can switch to two windows and they will not conflict in each other. So within our leaves, what I need is a vertex color. So you need to add a vertex color within these panels and set that to color and mix RGB. If you have watched my shader motion color tutorial, you probably understand why I do this. So I'm not going to explain exactly, and I'm going to take the base color. So now this is very cool. So now I have a trunk color, and then even if it goes to 1, it's still trunk color. But if by any chances you change the vertex color through animation node, you'll change that to green. And this is what we're going to discuss later. Actually, in fact, I think it should go opposite. So let's invert that. Also, one thing to mention is that I think in shader motion graphs, I also explained there's ways that you can actually use animation node to control all these parameters within the shaders. So I think it's possible that you even synchronize these two colors so that you don't necessarily concern about two panels in shader editor and so on and so forth. Or there's multiple ways that you can synchronize these two colors, but I'm not going to detail for each of them. Rather, I'm just going to animation nodes and let's start to work with the actual animation. I'm going to delete the original cubes. So first thing I need to do is basically just to distribute the entire trees over a plane. So I'm going to take a distribute matrices, object instancer, and object matrix output. So put the matrices into instances. So I generate enough amount of objects for each matrices and select our actually trees. Remember to tick on the copy for object and deep copy. And I think so now we distribute the trees over a grid. However, if your camera is zoomed out very far enough, then you see a grid of trees. And we definitely will add some randomness in its locations, but a grid is still a grid. But I don't like it, so I change that to spiral. And I'm going to take all the sides to 1. And the start radius probably large, and the radius probably large as well. Or it's finally something that you can potentially decide. But as you can see, if the end radius is small, sometimes it looks nicer. So finally you get everything into a spiral. At least you get a kind of circular fashion, which I think is kind of nice. Next thing I'm going to do is to just randomize their location so that you do not actually see a spiral, but we can definitely set a camera. Wait, where's my camera? It's because the end has been clicked off. Yes. So now it gets to views, lock camera to views, and then finally zoom in a little bit. So at least the cutting edges is kind of circular, so which looks nice. Okay, let's stay as it is. I'm going to add randomness in its distribution because otherwise the spiral shape has been looking so obvious. So let's take a offset matrices. Add a location, and let's add random vector. Actually, let's see. Yes, I'm going to add a random vector. And I'm going to tick on this list and put the get list length to the count. However, I don't want to all these objects to move on z axis, because if I directly plug that in, and increase the scales, you can see some of the trees just flies up. And this is not what I want. So here, what we have to do is just, there are essentially multiple ways. For example, you can separate vectors and recombine the vector, but finally, I think the easiest way is add a vector mass and multiply. So multiply 1 and 1 on x and y, but not doing anything on z. And now if you just increase the scales, they will just be randomized. And sometimes it can cause the intersection, but in general I think it's fine and not too obvious. So basically this is it. So you get a lot of trees, and it's feel free to play around with all the settings to see a settings that does not cause too much of issue. And within the scales, I'm going to add a random scale as well actually. So let's take a random number. So take a list and a vector from value. So now this is actually, so some of the trees is too small, some of the trees larger, and put the get list length to the count. So now we have trees of different sizes, so on and so forth. And with such a setting, I think we get a kind of very nice forest. You can definitely change the amounts for some of them to be more scattered. The next thing, I think it might be better if we firstly take all these trees into the cubic shape. So let's work with the shape keys. So let's type a shape key from objects. This node, however, actually does not receive multiple inputs. So if you directly put objects in, it has to get a list length. So convert everything into a single element. So here, what we have to do is, as usual, that you hit W's goes to right to loop through objects. What loop does essentially is that you input an object list, and this loop will be looped several times, and each time within a single loop it will input a single object from this list, and it will solve the problem of the issue that we saw earlier. And then we need a shape key output. Put the shape keys into that, and then we activate values. Put that into iterator, because different objects should have a different value. So now, because the default value is 0, so everything has been switched back to cube. So this is actually kind of nice. Cool. The next thing we need to actually work with is the translation of all these cubes. And this turns to be a tricky part actually, because if you don't have this random scale, then all our cubes will have a dimension of 2, 2, 2, and this applies to all cubes. So what does it means is that if you go to the Y views, you can move down 2, and it will be merged into the ground, and you move up 2, then it will be out from the ground. If you move out 1, it will be out from the ground, and if you move down the 1, then it will be merged into ground. But if you change the random scales, then each object requires a different values to be merged into ground and out from the ground. So how can we actually solve this issue? We are going to, it's actually very, very simple. So we're going to put a new offset matrix downstream to what we have earlier, and we are going to only change the locations. here I'm going to take a vector, actually float math, because random number is a float. I'm going to times 2, and I'm going to take that into translation. So let's combine vector, and we're only going to affect z. So put it into translation. So now you can see everything has been moved over the ground too much. So let's multiply to 1. And now it works, because it should be divided by half. We're only going to move the half value if your origin is in the center. So half half. So if the fourth is 1, then everything has been over the ground, as you can see. If the fourth is 0, then everything will be half merged into ground, and the rest of half is out from the ground. But if we are doing a constant fourth, take the fourth value to -1, then everything has been merged into ground. So this is opposite. Which means if by manipulating this fourth, we can decide whether this object is merged into ground or not. And we are going to use several random fourth. For example, we can directly use the random fourth to decide how object has been distributed over the ground. And if the minimum and the maximum are the same, then they will do the same behavior. So this is one way that you can potentially animate. So like you can animate the max and the minimum later, so that different objects will be out from the ground in different order. There's another way that you can do is called a wiggle fourth. Wiggle fourth at some point is the same as the random fourth. The majority difference actually comes from the fact of this evolution, because if you try to animate this evolution, you can see the jumps up and down. So this might also be something that you would like to play around with. There's also another option called a noise fourth. It's basically just one level more complex than wiggle fourth, and you get more options. Finally, by the end of the day, you can play around with all these options. In this particular case, I think I'm going to use the wiggle fourth, because it gives you essentially more kind of options to animate, as you can animate the evolution as well, in case you would like to do other kind of animation instead of the forest. To animate this wiggle fourth, we're going to use a node which is called the remap fourth. And when the wiggle fourth has an amplitude of 1, it actually means the outputs goes from 0.1 to 1. So we're going to change the input minimum to -1. And I've made a tutorial talking about how to animate animation node, because there is no keyframes available. So here I'm going to use a controller, which is a preset that I've built in that tutorial. If you don't have these presets, then you just use object transform input instead. Basically, they're doing the same thing. The entire whole point is I'm going to use the transformation data to replace to help keyframe the animation node. So here let's put the location x or y to -1, and let's hit a keyframe. And after about 20 frames, let's hit the y to 1, insert a single keyframes, and at 30 frames, let's put the location x to 1 as well. The whole point is what you can see is when the x and y is different, then there is a delay of action or random actions or random order that has been applied to each of the cubes. So while some of the cubes are already above the ground, other cubes are still under the ground, something like that. And until they both reach the 1, and all of them, they should be over the ground. And we can do the same thing to basically all the parts, like the shape key as well. And you can try to use the same wiggle fourth, or you can try to change the wiggle fourth so that a different order has been applied just by changing the seed. and use a new remap fourth. And here I need to convert the fourth into a float number. So I need to use evaluate fourth. And let's change the transformation matrices into matrices, fourth into fourth, and the strength into value list. Just remember that for the shape key, its output minimum should be 0. Then it's already the number that we are setting. And here I'm going to use another set of transformation sockets, which is the scale. I'm going to keyframes everything into 0. And after all the cubes are above the ground, then I'm going to keyframe the Y to 1 first. And then after a delay of actions, I'm going to keep the scale X to 1 as well, so that all the trees finally goes to the place. And now we have a forest growth. One more thing to essentially mention is that you can either try to change the interpolation of all these keyframes by hitting T, or you can try to interpolate the fourth as well. Interpolate fourth. It's possible to add a back. So back is a overshoot. So what you can see is in a moment that these trees are overgrown, but later they shrink back. So it makes kind of the animation more interesting. But of course, you can also make a customized interpolation by yourself through this curve interpolation node. So make your own back if you're not satisfied with what you are working by default. So something like that. Let's see. Yeah, it looks kind of more interesting. So play around with all these things by yourself. The last thing that I need to cover is about the color change of this entire thing, which is also called shader motion graphics in this case. It's actually pretty simple. So in my shader motion graphics tutorial example 2, I've built a preset which is called object shader loop. It's basically although it's called a loop, but it's actually a group of inputs, as you know. These objects does not go into a single object socket. So what you need to do is just hit W and it goes to right to generate a loop. And having a loop by itself can make an entire new preset that allows an input of multiple objects. So which I called object shader list. It's basically just a loop node feed within to the entire thing, and everything else goes to parameter. It's actually very straightforward. So in this case, I'm going to use my object shader list and put the output object list to the loop. And I think I'm going to use the same fourth that has been used to change the shape, so that the color change has been synchronized to the shape change. So now you can see how the animation goes. Everything is brown initially, but as the shape has been changed later, they grows to gray, which actually looks very, very cool. And this is actually all about it. And this setup is actually not very complicated. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.